Yeah, hello everyone. Yeah, good morning, good afternoon, good evening for the people who are attending online. So, I'm Dr. Swapna, working as a scientist in National Remote Sensing Center of ISRO, Hyderabad. These are my colleagues who have contributed to this work from National Remote Sensing Center of ISRO. I'm going to talk about the diurnal variability of INSAT-3D SST in the Indian Ocean, intercomparison with in-situ and satellite observations. Coming to the introduction, as we all know that sea surface temperature is an essential climate variable which used in climate studies, air-sea interaction, ocean mixing, boundary layer process, and to input the model as a basic parameter. So we use SST in most of our ocean and atmospheric applications. So this has a greater implication in climate, as we all know that temperature is increasing. So to understand what is going on in the global scale and regional scale, SST is an important parameter. That's why it is considered as essential climate variables. So coming to our ISRO, we have INSAT-3D. It is the Indian Geostationary Satellite, which is providing high temporal resolution, that is 30-minute SST data for the Indian Ocean region. So to best utilize this product, we need to assess the product, like how it is the quality of this product, and by comparing with in situ observation, we can know how it is going to be utilized in many applications from day to weekly and monthly scales of process, ocean process, to understand. So in this regard, I have used the latest version, that is INSAT-3D SST of latest version from May 2021 to December 2022 has been considered along with in-situ buoy-measured SST. And I have also considered the contemporary SST from MODIS satellites to understand the spatiotemporal variability in the Indian Ocean region. So after this initial assessment, I have studied the diurnal variability of the uh, INSAT-3D SST in comparison with the buoy SST. So this is the study area. I have chosen the North Indian Ocean, which contains Arabian Sea and Bay of Bengal. Here, around 15 buoy locations I have considered. These are 1 to 7 numbers are falling in the Arabian Sea, whereas these buoys are falling in the Bay of Bengal region. This buoy data is taken from uh, INCOI's Indian Moored Buoy network data provided by the Indian National Center for Ocean Information Services. The INSAT-3D data is with a high 30-minute interval from with 4 kilometer spatial resolution is obtained from Meteorological and Oceanographic Satellite Data Archival Center. That is, we call it as MOSDAC of ISRO, from the Space Application Center. And as we all know that MODIS SST data is taken from the NASA site, which is of level 3 product 4 kilometer spatial resolution data at aqua time, like at 1:30 p.m. we have considered it. Coming to the Indian region, it is around aqua is around 1:30 p.m. Indian Standard Time. So that product I have compared with the INSAT-3D data. As we all know that whenever we are doing any intercomparison or assessment, so we need to correctly match the in situ data with satellite observation. So for this, what the collocation criteria I have followed is the plus or minus 30 minutes for the in situ observations with the INSAT-3D SST. Like if any data is missing, satellite observation is missing, I can take the minus 30 minutes if any data is available, or plus 30 minutes if any data is available, that I will take. And I will consider for next temporal spatial collocation of plus or minus 4 kilometer. If in the at that buoy location, if satellite data is not there, so I'll look around the pixels within plus or minus 4 kilometer distance. If any data is available, I'll take that data. And so this is the collocation criteria I have used in this data. And as we all know that we need to consider some additional criteria like SST range like 5 degrees centigrade to 35 degrees centigrade, and the initial quality
We give them a couple of seconds to come back. Let's have a look.
Otherwise, I have discarded the data. So for this matchup criteria is followed, and for the satellite to satellite observation, more in comparison with MODIS, I have considered temporal collocation criteria, like which passes the same at MODIS same time. If the data is there, I will take the data. If no data is there, I don't take any other data. So this is the matchup criteria I have followed for this analysis. Coming to the results, as I told, I have taken 20 months of data from May 2021 to December 2022. That is the latest version of data. So if you see the left top figure, it is a scatter plot between the collocated buoy and INSAT-3D SST observations. So this is the buoy SST and INSAT-3D SST. I have found a very good number of observations of around 7,420. The correlation coefficient is very good, very strong, very strong, like 0.88. The error is 0.54 degrees centigrade, and bias is minus 0.22 degrees centigrade. See, actually, why I have considered this study is the previous version of data was giving high errors in terms of RMSE and biases. So, and correlation was also very less compared to this version of data. So, we have done that work and detailed analysis published in our journal paper in Swapna et al. 2022 in Progress in Oceanography. I'm going to give that reference in the last. So, this latest version of the data, the correlation and in terms of correlation and RMSE, these are all improved. So, and as we all know that the SST has day-night variation, seasonal variation, and regional variation also. So I have carried out the day-night variation and its assessment in with respect to the buoy observations. So if you see this table, for the daytime observations, we have found a very good, very strong correlation of 0.89, and RMSE is of the order of 0.53 degrees centigrade, and bias is very less, minus 0.15. And whereas for the night observation, it is relatively less compared to the daytime observations. And this downside figure shows the histogram of skin minus bulk SST difference. See, as we all know that satellite SSTs are skin SST. That means like satellite observations are of at a depth of 10 micrometers depth. It capture the informations of the ocean surface. So these are all called as satellite SSTs are all called as skin SST observation. So this skin SST minus bulk SST distribution is shown in Arabian Sea and Bay of Bengal. If you see this thing, in the Arabian Sea, AS means Arabian Sea. In the Arabian Sea, around 53% of data is showing negative. If you take the skin and bulk SST difference, whereas 25% of data is showing positive, and around 22% of data is on par with the in-situ observation. So this shows that most of the time the satellite SST is underestimated in comparison with the bulk SST. The almost similar cases observed for the Bay of Bengal. See, around 50% of data is negative, and the 29% of data is positive. 21% of data is on par with the buoy SST observation. So why these differences? As I told, this satellite SST is the skin SST, which comes from the 10 micrometers of the ocean surface, whereas buoys SST is at a depth of 1 meter. So whatever buoys I have considered in the Indian Ocean, those are of 1 meter depth. So the differences arise due to many factors like cool skin effects and warm skin layers effects of the satellite SST. So this shows that how we can correct for these these effects, and we'll get a good comparison with the in-situ observation. That will be my further, that I am going to further analysis after this work. And if you see this, as I told, it has regional variation also. This in the Arabian Sea and Bay of Bengal also. We have done this analysis with respect to the buoy SST. So in the Bay of Bengal, we have found very strong correlation of 0.9 with a low RMSE of 0.53 and bias of minus 0.25. Whereas in the Arabian Sea, the correlation is relatively less compared to the Bay of Bengal, and RMSEs are the order, RMSE and bias are the order of similar to the Arabian Sea. Coming to the diurnal variability of INSAT-3D versus buoys SST. As I told, initial assessment with respect to the in-situ buoy observations is carried out. Then my focus is on the diurnal variability. As we all know that diurnal variability is caused due to the Earth rotation and solar radiation. So due to this, we observe changes from day to night. So how well the INSAT-3D SST capturing the diurnal variability in comparison with buoys is carried out in this study. As you see, these are the typical diurnal variability at the buoy locations mentioned in my second slide. So if you see, the buoy SST dotted line shows the buoy SST observations, whereas the line profile shows the INSAT-3D SST. So more or less, both of them are representing with minor changes of around 0.2 to 0.5 1 degree change difference. They are following the similar pattern. And if you observe this around 2:30 p.m. For our India, these times are all in Indian standard times. You can see around 2:30 p.m. means in the afternoon time, we are finding the diurnal peak in the Arabian Sea and Bay of Bengal. This is for the Arabian Sea location, and this is the Bay of Bengal location. And if you see in the evening and night times, we the INSAT-3D latest version also reported the nighttime calibration problems. So nighttime we could not find that good match at many times, but however sometimes we could find very good match. So if you see the coming to this Bay of Bengal buoy SST versus INSAT-3D SST, these are also very good in comparison, and the diurnal variability is represented well in these from these buoy observations. And as we know that diurnal variability means we have to know, we can calculate the diurnal magnitude also, like from the day observations to night observation, what is the difference, like what is the magnitude of the diurnal variability. So I have calculated the magnitude of diurnal variability on a daily basis from nighttime observations to daytime observations. So I found for the Arabian Sea buoy locations, see the buoys in the Arabian Sea are giving 0.2 to 0.4 diurnal variability, diurnal magnitude. If you go to the INSAT-3D SST in the same Arabian Sea, the magnitude and diurnal SST magnitude peak is occurring at 0.2 and again at 1.2. Means in the satellite SST, the diurnal SST magnitude is high compared to the buoy SST. Here it is following the peak is occurring at 0.4 degrees, 0.4. But whereas here two peaks we can see, like one is at 0.2 degrees centigrade, and again it is high. Many observations we have found at 0.2 degrees centigrade also. So coming to the Bay of Bengal locations, here the same similar 0.4 degrees centigrade is the diurnal SST magnitude for the buoys in the Bay of Bengal, whereas for the INSAT-3D SST, you see it's around 1 degree centigrade. Here in the Bay of Bengal, it is a diurnal SST magnitude is very high compared to the Arabian Sea. And as we all know that Indian Ocean is like warmer ocean in the in all the oceans. So this study says that it is some many other ocean processes are contributing this diurnal variability SST magnitude increase. So that initial study showing, yeah, it has some impact in the SST diurnal SST magnitude increase. So further this analysis can be used why this kind of variations for the regions like Arabian Sea and Bay of Bengal, if some more buoys are available at the equatorial Indian. So this study will these results will be used to analyze why these are causing this kind of variability in the SST. So if you overall, if you take the diurnal average diurnal variability of INSAT-3D SST is coming around 0.87 degrees centigrade, and buoys is coming around 0.54 for the overall North Indian Ocean. As I told, the buoys are at the depth of 1 meter, whereas the INSAT-3D is at the skin temperature. So it has got large variation due to cool skin effects and warm layer effects in the skin layer. So that results, that is means that is resulted in this diurnal variability SST magnitude also. And coming to the INSAT-3D versus MODIS SST comparison, this this is the region I have considered from 65 degrees to 100 and 0 to 26 degrees north. This is the region I have considered. So if you see, this is the spatial correlation map of INSAT-3D versus MODIS. So I could see very strong positive correlation in the Arabian Sea and Bay of Bengal. Here most of the time data were missing, and as we all know that equatorial Indian Ocean is a very dynamic and complex in nature. So overall in Arabian Sea, Bay of Bengal, they are representing very well, like in spatially and temporally. And we have found a very good correlation of overall correlation of 0.86 and a bias of minus 0.1 and RMSE of 0.6. So if I take the latest version of INSAT-3D SST, I could see very good improvement in terms of statistical parameters like RMSC, bias, and correlation. So to conclude my this talk, I can say that I have taken the latest version of INSAT-3D SST, assessed the day, night, and regional SST with respect to the buoy SST or the North Indian Ocean, and found a very strong correlation of 0.88 with a RMSE of 0.54. As I told, I have taken the previous version of INSAT-3D SST, so where I could see RMSE of 1.28 and correlation coefficient of 0.7. The detailed results were published in Swapna et al. 2022. So from 1.28 of RMSE to 0.54, from a correlation coefficient of 0.7 to 0.88, it has improved a lot in terms of the statistical parameters. So, and daytime data are relatively better in correlation compared to nighttime SST data. As I told, we have that INSAT-3D SST has that nighttime calibration effects due to geostationary platform. So this is expected. So, and as I told, skin SST has large variability in comparison with buoy SST. And it has the skin SST, that INSAT-3D SST has shown high average diurnal variability of around 0.86, and whereas buoys have shown 0.57. 7 degrees centigrade. So overall, what my conclusion is that the version 2 of INSAT-3D SST has shown high diurnal variability magnitude that from version 1 of INSAT-3D. Like if you see initial version of data, it was showing 2.24 degrees centigrade diurnal SST magnitude. Now it has decreased to 0.86. So it has improved a lot in terms of representing the diurnal variation throughout the day and reduced the diurnal SST magnitude compared to the previous versions of INSAT-3D SST. And along with this, the contemporary satellite observations also very good spatial and temporal consistency we have observed. So my conclusion is that the latest version of INSAT-3D, which is derived using 1D wire technique, has shown improvements in terms of RMSE and R, and well represented the diurnal variability in comparison with the buoy SST. So as I told, the detailed results of previous version of INSAT-3D SST is find out. You people can find out this paper INSAT-3D SST and its diurnal variability assessment using in-situ and MODIS observations. And the latest version of INSAT-3D SST implemented from 2021. So the methodology and all are given in Gangwar and Tapliyal. So you can refer this paper for the latest version of this thing. And as I told, the data, I acknowledge IMB network for providing the in-situ observations and ISRO's MOSDAC for providing INSAT-3D SST data, and MODIS SST as data has taken from the NASA NOAA. These data sets are great. The data providers are greatly acknowledged, and I thank Director NRSC for encouraging to carry out this work. And this work is carried out as part of National Information System for Climate and Environmental Studies activity of NRSC ISRO. Thank you one and all for your kind attention.